Okay, so spreadsheet parallel optimizations. Um, they've been in LibreOffice for years, since 2017. I won't pretend that I have done any of the actual important work. There's a whole list of people there, Lubosh, Tar, Michael himself, a whole bunch of people involved in actually doing the real work. But my vague understanding of it was that the general part of it was put up on top of some OpenCL work, and a lot of that involved getting formula groups, groups of formulas where the formulas are all effectively the same, looking at the dependencies, and being able to see what kind of formulas you could run in parallel. The important bit in Calc is the SC interpreter that does most of the work, and a lot of the work done at the start of this process was getting rid of global state and local statics, and moving a lot of the state that involved that started off in the Calc document itself, and moving it out into an SC interpreter context to allow you to have multiple SC interpreters running at the same time, so you could do parallel calculations, one per thread. So what we discovered, or it was brought to our attention, was that there are certain circumstances where this threading work was giving worse results than if you had had no threading at all in the first place. And a particular example that was given to us is this ODS there, and in the slides it links to the repository where we have this example document. And the problem being that there was so much locking going on between all the threads that the amount of locking was taking far more time than the advantages we were getting from threading. So the actual amount of locks was much significantly longer than the actual parallel work itself. And what shows up quite regularly in the profiles is this SC number formatter and one particular method, the get format for languages if built in. So what that looks like for us and how we profile it is that we're just using perf and then flame graph to render it. And as in this morning's one, brief description of the flame graph is that the width matters. The wider something is, the more proportion of time it is taken up. And then from the depth, you can see what calls what. And the colors are not significant in any way, on these ones at least, except just to see the differences between them. As a feature of this, in the bottom right hand corner here, if you search for something, and in this case I've searched for pre-thread mutex to see how much time has been taken up by mutex, you can see that there's 40% of the overall time of calculation is actually just being stuck with the mutexes calling each other. So you can get a quick overview straight away that their problem is clearly here, and one of the reasons for the problem is our accumulation of p-threads there. What you're hoping to do is to reduce that. So, as I said earlier, the actual thing that does the work is the SC interpreter. There's SC interpreter contexts that SC interpreters use, and there's one per thread. And the idea is that you should be able to get as many interpreters running at the same time as possible without any contention. But they all have to operate, or they all operated on a single number format, or one per document. So no matter how many threads there were, everything had to bottleneck through this SC number formatter. Why? Because in the general use case, you can write to it. So if you have a document that's blank and you type in a number and you say you want this number to be in German or whatnot, on demand it creates the information about that language and adds it to this number table. So it doesn't have all languages stored in it from the very beginning, and you can create your own custom number formats as you go through a document as well. So it's writable, and because it's writable and because it's one of them, it has to assume that it can be written to at any time, and it has a mutex locks. But we get into resolving that. So where were we now? Right, so let's just focus in on that get format for language built in. So that is it there. Again, the 40%, just focusing on that and what to do about that. So looking at it a bit further, what does that actually do? It doesn't actually do a whole lot. You get two inputs into it, a language and an index, and returns back another number. So it should return the same thing it's called every time, at least during the purpose of interpreting the calculations. So if you call one thing, you get a particular result back, and then each time we've locked it, we get the same result back. So there isn't any need for it in the sense that it's not modified, and in this particular context, it doesn't matter. And in the document we're talking about, it uses 4 different combinations here. So if we add in a little cache that's not locked for that, we can get most of our benefits straight away without modifying anything. And there's already a cache for a similar situation in this case. So if we just add in this little 4-entry cache, we go to a case we've gone from 40% of our time is in this mutex, and we're down to 4% of our time is caught on that mutex instead with our little cache. So we reprofile again because we focus in a small area. The overall results aren't great, and we have a look here to see what else is showing up as being interesting. This one is SC random. The spreadsheet itself calls random quite a lot, and again we see that there's still these mutexes being called every time you're calling random. So we can look at that a bit closer. And we see then that we have over in comp helper or random number generator, we have a single one for the entire Office suite, and we have a single generator backing that up. But if we put a individual generator into each individual interpreter context, one per thread, then we don't have a locking difficulty in a particular thread to get a random number. We can just have thread X random number generators, which gives you basically a mutex-free world. So we no longer have any obvious locks at this point here. We have things that call things, obviously enough, but then we have this kind of mystery blank area where there's no obvious functions calling another. It's an optimized build. These are all inlines over here, so it's kind of hard to see them. So I look a bit more fine-grained at some of the other tools that are available. You've got Hotspot, you've got Intel's VTune. They can give you a kind of a more fine-grained look at things than you can easily see in the flame graph. So here then we have a little look here into this flat area that doesn't have obvious peaks. And in this one we found a couple of interesting things. One I thought was particularly interesting is this intrusive pointer one here, where in this block we're getting this percentage of time being eaten up by just constructors and destructors on the intrusive pointer. So we have a look at the actual code of where this is coming from. It's coming from just this find here, and it has this pointer is being set in, and it is apparently just looking up something, and that's taking up a suspiciously large amount of time. I have to look a little bit deeper into it. That's the thing that we were calling find on there. Now what it is this, and it's just a map, and it's using this particular lookup to find something inside it. What's actually happening is that you're being passing in a formula token pointer. A formula token pointer is being used as a constructor to make one of these things. Well, the map itself isn't the problem. What turns out to be the problem is the construction of these things from that thing, from the pointer to that thing. It's not the blockage in this case. What's happening here, as I said, is this thing has been constructing one of those and one of those. And since C++14, this kind of scenario is a recognized scenario where it can create temporaries like that. And you can instead add in extra operators that take the thing that you are passing in, and you can do the conversion, the comparison without the conversion. But what's kind of obscure, I found it obscure at least, is that to enable this, you have to explicitly specify that you have a transparent comparator by adding in this bizarro using is_transparent, which was news to me, seeing as that particular change in C++14 had passed me by. But if you go search for is transparent, you'll find out that Noel, for example was well aware of it, and you can find a couple of other cases in there. So anyway, if you come across is transparent, it's to enable this to become a transparent comparator, and by doing that, you can avoid creating any of these temporaries, and you can avoid that kind of problem we were seeing in the boost intrusive pointer, which doesn't exist at all anymore because this lookup no longer needs to create temporaries. So a kind of a hidden case there. So that was the kind of first simple obvious things. But then going back to the area issue that we kind of worked around with the small cache, which was fine for that particular document, decided to tackle the overall problem of having the number format table that we should be able to drive in a read-only way during calculation and not worry about any writes. So it was a challenging problem, but what we've done there then is, or what I've done there is, we've created a read-only mode for the number formatter, and we can split it up into three major areas. The language data, that is a kind of a temporary thing that's thrown away. You change your language as you go through the document. It's a multi-language document. You can throw away your language data at any time and recreate another one without any particular difficulty. So there's no important state in language one. Your format data is your important state, and then you have this number formatter engine that operates on the two. So the number formatter still exists, but the number formatter is now defined in terms of these three parts. And there's a policy. There's a read-only policy and a rewrite policy. On the rewrite path, any of the writing issues are all blocked by mutex. The reading ones, when you're in read-write mode, are also blocked by mutex. But if you want to operate in read-only mode, you can operate the whole thing without a mutex. And attempting to use any of the other one isn't possible if you go through the read-only policy facade. That's a big knock-on effect there. As we went through all the code that caused what, we found a whole bunch of places where there's little hidden states hidden about the place. And then they has to be determined, is that state a language-specific one that can be thrown away, or is it a format one, in which case it's something that needs to either be put into a certain place, or much more practically, before you use something in read-only mode, you have to determine default currency. So you have to pass in the default currency, because that's something that otherwise would be determined on demand. So to keep things simple, read-only mode requires a couple of things to be set in advance, such as the default currency. And once it knows the default currency, then that state exists, and it doesn't have to do any kind of queries, and you can move the things that modify stuff into your rewrite policy, and the rest of it comes through. So it's a difficult iterative process, but it does give you in the end a lockless number format or facade that we can use during threaded parallel threaded compilation. Just to give you an idea then of what kind of numbers look like with that. If we operate with no threads whatsoever on that sample document over whatever 10 or 20 iterations, this is the kind of real-world stopwatch time you're getting. When the threads were enabled, things got worse on my, 12-core box. And then after these modifications, at this stage, we're down to 3,000 milliseconds. So it's far superior than the single-threaded case. You're getting your advantage from your threads, and it is, of course, far superior than the awkward situation. That's kind of stage one. Things aren't great at this point. They're better, but it's interesting to see where is that remaining time. We don't have mutexes blocking things anymore, but there's still issues that are related to threading that's causing problems. And we can see is that we're spending a lot of our time in incref and decref. They're using our OSL atomic increment, but it's basically the same thing as a standard atomic, in the sense that you're incrementing and decrementing thread safe values, which is supposedly better than locking in mutex and incrementing and decrementing an ordinary value, but still not as free or as cheap as I thought they would be. So a lot of your time is spent just incrementing and decrementing numbers. But during this threaded calculation, the things that you're incrementing and decrementing are these formula tokens, which are part of the tokens used to express the calculation chain. And in theory, at least, when you start calculating and when you end calculating, all of these increments and decrements should balance out. You should be in the same state as when you started. So for this period of calculation, all these increments and decrements are unnecessary. So if you could just not do them, you don't have any of this increment, decrement, contention issue. And it's all, at the moment, at the time, it was all busy work to achieve something that if it never did it in the first place would have have the same result. So what would happen if we could just disable that reference counting entirely during this area? So that's what it looks like as in a patch. These are the formula tokens that have showed up earlier, which is the crucial path. What it was doing is just incrementing the number, and now it has a policy where it's by default does the same thing. And another option is to do nothing at all. And then there's another case where you just reference the number without paying any attention whatsoever to any kind of thread 7 increment. So as it turns out, this case, this middle case, also showed up, whereas there is a per interpreter cache of formula tokens that only that particular context uses, and that context is one per thread. So they're thread private cases. And in the thread private case, we can set the unsafe ref policy for those ones. We can increment those ones because they're private to us. We don't need to worry about anything. And it's more of an oddity than anything else. For the other ones that were passed in that we know we're going to leave in the same state what we started with, we can turn off any reference counting whatsoever during that period, and then we can restore reference counting when we have finished thread calculation. And the actual amount of formula tokens we're talking about is relatively tiny compared to anything.
So I noticed both in this case and the previous and the change that you mentioned, you're adding like a modes or policies to a class, and not, but as a variable that exists as part of the instance. So is there an design consideration why not, for example, to templatize these choices?
Well, yeah, in the case of the formula tokens, the one you're passing in at that time, you will have to put it back the way it was, and you will have to operate as you normally do. So you're not you're looking at a thing that needs to behave differently under different circumstances, unlike the template one. And I suppose the same is kind of true for the number formatter as well. You could imagine that you would just do it as a template, but it's just far more straightforward just to have two simple classes rather than saying, I think I tied with it and it just got additional complexity and I needed things simple. Which yes, oh yeah. So on the thread safe thing, the theory is that it's going to be the same as you start and the same as you end, and it really should have been like that. But there's always complexities with these things, and nothing is ever as simple as it should be. In practice, the interpreter contexts themselves, even though they were each one is per thread, they had caches, and they would cache some of these things. And while those caches would eventually be emptied, they weren't emptied at the right time that was useful for us. They were emptied after the parallel calculation had ceased. So it took quite a bit of effort to discover all of those and move those all into the right place so that the reference counting could be contained inside or at least balanced on each side of your block that you're calculating. So anything that takes place inside the start of calculation has to be undone inside calculation, and anything beforehand has to be done afterwards. Just to get those all entirely balanced out took a significant amount of time. But yeah, that was all pretty much balanced out there. It took a couple of weeks, and these results then. Same numbers as before. This was 3 point something seconds, and now it's 2.5 seconds. So you're getting like another 0.8 of a second knocked off the best case scenario when you had no mutexes. From no mutexes to hidden hardware contention on atomics, down to that as well. And then additional smaller things, they all add up in the end. Extra caches for a few areas, a few bits and pieces. And best case number then is 2.3. 2.3 for this particular example. So yeah, that's the last slide on calc threaded stuff. If anybody has any other questions? Yeah, go for it. Actually, Sapper first. And then.
So one question I have is, you mentioned that these caches and simulation were kind of hand-tuned.
Where I just said I added 4, yeah.
Yeah. Let's say I was working on a bug and I came across these classes. I changed some stuff around just to make it work. Will it need again hand-tuning, or
Yeah, I don't think so.
generally okay?
I think at the very beginning, for this particular document, I picked 4 because that was what worked for me. But then afterwards, I think I've replaced that now by a kind of a more generic, most recent. Well, there is a less stupid way of doing it now that does not involve the number 4, but it is fundamentally because 4 worked, and now it's a more sophisticated version of 4. But yeah, it's like whatever's been used in the last, sensible amount of iterations. So. Yeah. Well, it should work for at any number, so if it needs to be increased, but I don't think in practice it's going to make much difference changing that number from what it is.
So my question was, my question was about the difference in behavior with different numbers of threads, and also if you have like single socket versus multiple socket, does that have any interesting effects? More related effects on things?
Well, at the starting situation of at the starting situation, the more threads you had, the worse it got. So you in this particular document, which was particularly poor because it was using a particular amount of random and so on. The more threads you were throwing at it, the worse you were actually getting it, which I guess is why it became kind of more problematic more recently as more threads become more common.
Yes, I was going to ask you about the documents that triggered this improvement, because it's a Monte Carlo simulation.
Yeah.
So I was going to ask you about how it was implemented, but you sort of answered it because it was a lot of random calls. So the user probably used calc formulas to generate the numbers on the fly instead of using like a macro. So,
Well, it does call SC random explicitly. Yeah, yeah, yeah.
so maybe couldn't the problem be related to how the user organized the document, or maybe the document could have been created in a more intelligent manner?
It could have been. It could have been. But yeah.
Oh,
Well,
yeah, but by the
well,
way, was there like a benchmark against Excel?
So yes, things are great in document library. And it is one of those benchmarks.
And how do we compare?
There's also macro to generate random
yeah,
numbers.
Yeah.
Slower.
yeah.
Not parallel lines.
There is macros involved in this, but the macros themselves don't call random. The random is called by the spreadsheet. The actual length of time of macros isn't in this one, but what I'm just focusing on is only the spreadsheet part of it. There's another big wide part of how slow Star Basic is, so that's kind of shockingly slow, but that's not the focus. All that stuff, details of like where the document comes from and why that document are outside of my zone. It's not an option, no. Okay. Anything else? Okay, very good. Okay, thank you very much.